Welcome to Trigonometry. In this video, we're going to do some homework problems that have to do with lines in the plane. The problem that we're going to do is we're going to find the slope and the y-intercept of the line 2x minus 3y equals 15, and then we're going to sketch the line. So this is the equation of the line that we're going to deal with, and it's written in general form, which makes it a little bit tricky to read off the slope and the intercept. But the easiest thing to do to find the slope and intercept is to put it into slope-intercept form. To go from the general form of an equation into slope-intercept form, all you have to do is solve for the variable y and simplify the right-hand side. So we'll solve for the variable y here by first subtracting the 2x to both sides, which will yield negative 3y equals negative 2x plus 15. Then we'll divide both sides by negative 3 to get y on its own here. Now, when you divide by negative 3 on both sides, you have to make sure you do it to the entire side of the equation. And this means that you're going to divide negative 3 on both of these guys. So if you separate this into two different fractions, you'll have this: y is equal to negative 2x over negative 3 plus 15 over negative 3. For negative 2 over negative 3, the negatives will cancel, but you can't do much with the fraction besides that. And so this will just produce y equals 2/3 x. But then for this guy here, 15 divided by negative 3 is negative 5. And so this will produce a minus 5. And this will be the slope-intercept form of the equation of the line. Now, the slope-intercept form, if you remember, is given as y equals mx plus b, where m is the slope and b is the y value of the y-intercept. And so the slope of this line will be m is equal to 2/3. And the y-intercept, since it's a coordinate, we got to give both an x and a y value for it, but the x value of the y-intercept is always 0. And so this will be 0, and then the y-intercept b, which is negative 5. And that'll be the y-intercept of this line. So now we have the slope and we have the y-intercept. The next part of this question asked us to graph this equation. So let's erase some of our algebra here, keeping just our slope-intercept form of the equation, which was y equals 2/3 x minus 5. To graph an equation of a line, all we need to do is to first plot a point, and then we can move to another point using the slope. So here, if we draw a graph, we want to first plot a point we know. The only point we know on this line is the 0, negative 5, which is the y-intercept. So we come down here to 0, negative 5, and that's this point right here, and we're going to put a big dot there. So that's our first point, is at 0, negative 5. We can get another point by using the slope. Now, the slope is given as a rise over run. The rise tells us how much the y value should change when we change the x value by the run. So here, this is telling us, since this is equal to 2/3, it's telling us that if we move to the right by 3, we need to move up by 2. Remember, positive for rise is up, negative for rise is down. Positive for run is to the right, and negative for the run is to the left. So this is a positive 2, which is an up movement, for every positive 3, which is a right movement. So here we'll write down, we'll go over 3, 1, 2, 3. That'll put us here, and then we have to go up 2, which will be 1, 2. So 1, 2, and that'll put us at about this point here. Once we have that, all we have to do is just draw a straight line between them. And you can sketch this. It doesn't have to be perfect. If you want, you can use a ruler and be really accurate, but we'll just try to get our best shot. That's what the line would look like in this case here. And that's it for today's video on trigonometry. If it was helpful to you, please like the video and subscribe to Trigonometry. The only way we can continue to produce video content like this is if we get help from subscribers like you. And so if we helped you, please help us out by liking and subscribing to this video. And we'll see you next time on Trigonometry.